So welcome to Refactoring Rules. Now you can take that to mean the rules of refactoring, or you can take it to mean that refactoring is pretty cool. Either way, I think both apply. In this video, firstly, in an instance like when we want to get the start and the end point of this line trace that we're doing, you could return a struct with two vectors in it. You could use out parameters, or you could use multiple getters to get the two different vectors. And we're going to be doing that in this refactor. So in general about refactoring rules then, less lines of clear code is better than more. So we had 143 at the start in my code, and by the end of this video I'll have 122 lines. So that's about a 15% reduction in the number of lines of code, and it still works, and I think that's a good thing. I want to reiterate that naming is really important. Take the time to think about the names of things. It's worth changing them. Now, commenting. It's good to comment why you're doing things. Don't assume it's obvious why you're doing something. But the what should be obvious. If the what's not obvious, then maybe you want to add some further comments for clarification. Okay, so we want the code as self-documenting as possible, but adding further comments for clarification is just fine. So let's recap this red-green refactor. Remember, we start off when we start a new thing with something not working. So our physics handle wasn't working. We then just got it working, and we made a commit over here. It was this one using physics handle. So that was our green commit. And now we're going to refactor. So the whole purpose of what we're going to do next is refactor and make it pretty. So you can say that, by the way. You can write your commit message. I quite like to do this before we even start coding. Then that reminds you what your little micro sprint is. What are you doing in the next section? So my video is called Refactoring Rules, but you may want to make a commit that is something like refactoring physics handle code. And then that would get committed next. All right, so that can be a really useful thing to do, is so that you know, and your message will stay, by the way. If you go back to commit, it'll stay here. You can always refer to that and say, what am I doing right now? What am I doing? Well, I'm refactoring. I'm in the blue stage, okay? So this accesses a memory layout. That was getting something working. This reducing code was a refactor commit, and you might want to standardize to the first word being refactor. And then this was getting something working, and now this is another refactor. A couple of other things on source control while we're here. I don't really like this .opendb file being tracked by source control. It's a lock file, and it's there whenever Visual Studio is open. What it kind of forces you to do is close Visual Studio before you commit. But the problem with that, if you get in the habit of just closing, if you don't say yes when it asks you if you want to save everything, you could lose your work. It's better to positively save your work and not worry about whether this .opendb file is there. So I'm going to ignore the opendb file. I'll go and get its name from here, from the file system. There's another file I'm going to ignore, which is the .solution file, and the reason for that is if we look back at using physics handles, the changes in it aren't helpful to us. It's a generated file anyway, so I'm going to get rid of those two. Just as a recap, you go find the git ignore, you add the things you want, star.vc.opendb and star.sln, pop those into the file, save the git ignore, back over in your source control, you may need to do a refresh. It will then notice in the uncommitted changes that there's a change in the git ignore. You just add that, and that's all we need to do for right now. So we're ready to go. We know what we're doing. We're going to be doing refactoring the physics handle code, and we've ignored what we need to. Let's go get on with the refactor. Not so easy, of course. I want you to do it. Refactor your code, yes, again. Yes, it's soon, but as I've said, clarity is worth fighting for. We want to get in that discipline. Commit your work once it's done and it runs well, and make sure it's so clear you'll remember in a year. So go ahead, pause the video, and have a go at your own refactoring now before watching my solution. So let's just start at the top of grab a CPP, go through, make sure it's clear. Again, yes, we're refactoring again, as I said. That's fine. So less lines is better. Let's get rid of spaces we don't need. I want to see what's happening in begin play. I'm going to change this one round. Rather than if physics handle, I'm going to say if physics handle equals, remember, null ptr, i.e. if there's no physics handle attached, then we're going to log the error. Yes, we could use an assert, but we'll introduce that later in the course. So that's less lines of code, so that's better. Remember, we started off at 143 lines or something like that. Let's see what we can get it down to while still being super clear. I'm going to collapse that down. That doesn't change the number of lines, but it makes it clearer. Set up the input component. I don't think we need to say that it's found or that we're binding the axis anymore because the code says that. So that's fine if input component exists. Otherwise, log an error. Good, that's clear. Close that down, drop the gap. Called every frame. Now this bit is horrible here. This bit here about getting the player viewpoint, this tick, that is a separate method. So let's refactor that out. I'm going to take that out. I'm going to make a method called get player, or actually, what am I getting here? I'm getting the reach. Getting reach line end is what I'm really doing in this method, isn't it? I'm getting the reach line end. So let's just make a method. A helper method, so I'm going to put it at the bottom called get reach line end. Pop all of this in it. And let's go, not void, f vector. It's going to return an f vector, get reach line end. Now, by the way, in terms of your refactoring, either watch what I'm doing or refactor yourself at the end. I'm going to challenge you at the end to refactor this. So it's entirely up to you how you do your refactor. If you're a beginner, you may want to copy me. If you're an expert, you may want to do things your way. I'm just trying to teach you the thought behind how I'm refactoring. So get reach line end, and then let's pop in some braces. Now, what of course we can do at the bottom is, rather than making this intermediate variable, we can just return that result. Return the player viewpoint location plus the rotation vector times the reach, and that's it. Do we need to say get player viewpoint this tick? Not really. It's not necessarily this tick anymore. Anyway, it's when we call get reach line end. Okay, so one more thing we need to do, of course, is put uGrabber, fully qualify the class name, the colon, remember, because it's known at compile time. And then let's go and declare this thing, or right-click, quick actions, create declaration. And with a little bit of time, it will do that. Let's go check that it's in a sensible place in grabber.h. It is, apart from it's bound there. So I'm going to do this and say returns current end of reach line. And this, of course, would allow us to have a reach line that changes during the gameplay. If we're going to get the end of the reach line, I bet that we're going to be getting the start of the reach line as well. Okay, and then let's go and define another method, which is for the get reach line start. I prefer start to come before end. Copying and pasting code because it's so similar. And what we do here is we allow ourselves to copy to duplicate this first little bit of code, these lines I've just highlighted, and then we up to twice, I don't mind duplicating code like that. And then we just return something a lot simpler in this case, which is just the player viewpoint location. So we have get reach line start and get reach line end. They are nice and simple. Now, let's go use those. Let's go use this get reach line start and get reach line end. Where's the first place we need it? So we do the super tick. In the tick, we find out if the physics handle's attached, then we move the object we're holding to what? To get reach line end. That's a bit clearer, isn't it? And then that's called once per frame that we're holding something. So that's okay. Then how does the grab work? Well, grab pressed. Don't know if we need the log anymore as it works. Line trace to see if we are reaching any actors. Yeah, that's fine. That comment does clarify things. So that's one of the things you're checking for. If we hit something, then attach a physics handle. That's fine. I don't think we need to say that we're attaching a physics handle here. Where are we grabbing? Yeah, that's right. We can't use the reach line, but we're grabbing at the location of the actor. So that's all fine. No bones needed. This component that we're grabbing turns out to be the mesh, but I'm not going to comment that. Let's leave that. Release, grab released. Don't think we need a comment anymore. Get first physics body in range. Now, that's got a load of this stuff. You see all that stuff? We've separated it out, haven't we? So we can delete all those lines of code. We can bring all our query parameters together. And then where it says we're raycasting from player viewpoint location, we're playing from get reach line start, like so, 2, get reach line end. Reads a lot more nicely. There you go. Nice. See what we hit. We don't need to do that here anymore. And just return hit. Don't like hit. I like hit results. So let's rename. Control R in Visual Studio. Hit result. Looking a bit better. Get reach line end. What's wrong with that? Get reach line end. Let's check the header file. Get reach line end. I don't think there's anything wrong with it. I think it hasn't caught up. I know, I can't spell. Cool. I think that looks and feels a lot better. A final thing I like to do is just have a look through it all and make sure that we are happy that what's commented needs to be commented, that comments talk about why, or if they talk about what, then they only talk about what for the sake of adding clarification, and that all of our code will make sense to us in a year. So here's something to remember. Will it be clear in a year? So you come back to this in a whole year, would you still understand what on earth you are doing? I'm going to say what we get here. Component to grab gets the mesh in our case. If you log out this component to grab, you'll find that when you get the hit result back and you get the component, it's the mesh component that it happens to be. So it's the mesh that we are moving down here. Release just releases, couldn't be simpler. Get first physics body in range, line traces out to the distance and returns what it hits, provided that it's a physics body, which is why that's in the name. That's good. You could, of course, make this physics body a parameter, so you could get first object channel in reach or something, but this is fine. Don't make it more general than it needs to be, earlier than you need to make it general. The only thing that's slightly grating is that you've got 2 bits of code duplicated here, but the only other option is to either return a struct, which is a bit over the top from here, or to use out parameters, which I'm not a great fan of. So that's it. Of course, the most important thing now is to check that our refactor works. Now, if you're less confident in refactoring than that, you need to just do it in smaller lumps. Change something, compile, check. Change something, compile, check. The important thing is it keeps working and that you've got this safety net of the using physics handles commit, which will work because you checked it before you saved it. So we can pick, we can drop, we can pick, and we can drop. Wonderful. Look at that. Great. So we now have nice looking code that still works. So just finally commit your work as a refactor. We already have the commit message, remember, and we are good to go.